students, welcome to the lecture number 11 of chapter 6. In lecture 10 we have discussed that according to the axiom 6.3, if a transversal line intersect two parallel lines at two distinct points, then all the pair of corresponding angles formed are equal. As there are four pair of corresponding angles and each pair of corresponding angles are equal, right? So this is the axiom number 6.3 and it is the most important concept as it has wide range application all over the chapters. Okay, by using that axiom 6.3 we will prove many theorems, many deductions in the exercise. Today in this lecture we will prove another theorem by using that axiom 6.3, right? So our today's topic is theorem number 6.2, right? So let us first understand the statement what is given in the theorem. Okay, so in the theorem it is given that if a transversal line intersect two parallel lines, then each pair of alternate interior angles is equal, right? So we will first clearly understand this concept. So it is given that if a transversal line intersect two parallel lines, right? So there are two parallel lines AB and CD. Now these two parallel lines are being intersected by another line that is known as a transversal line PQ at 2 point M and right. Next, then each pair of alternate interior angle is equal. Now can you find how many alternate interior angles this figure have? As I have told you, alternate interior means the two angles must be interior and they are opposite direction. One angle should lie towards this side and another angle should lie towards this side. Then two angles are known as alternate interior angles, right? So here this angle and this angles are alternate interior. Why? Because this angle lies towards this direction and this angle lies towards this direction and both are towards the interior side, right? And they are also non-adjacent. So these two angles are alternate interior angles. So you can write what is the name of this angle? BMN, right? So BMN. And another angle is this CNM. CNM. So these two pair, this is the first pair alternate interior angles. Now let us find the second pair. Now this angle and this angle are also alternate interior pair. They also lie in the opposite side. They are interior and non-adjacent. So you can write AMN, this angle AMN, and this angle means DNM. DNM. So as a whole we have two pair of interior angles when a transversal line intersect two parallel lines. Now according to the theorem 6.2, you have to prove that the pair of alternate interior angles is equal. It means you have to prove this angle is equal to this angle and this angle is equal to this angle. Understood? So you have to prove this angle is equal to this angle. So and this angle is equal to this angle by using axiom number 6.3. Okay. So let's proceed how to prove it. Okay. Now you understood? We have to prove these two statements, right? So first you have to write what is given in the statement. Okay. So what is given? It is given that AB and CD are two parallel lines. AB and CD are two parallel lines and PQ is a transversal line. PQ is a transversal line which intersect the two lines at M and N. Which intersects at M and N. This is given. Now, whenever this intersects these two parallel lines at M and N, then how many pair of alternate interior angles are formed? Two pair, right? So then, two pair alternate interior angles are formed. Then what are they? The first pair is, as I have told you, this angle and this angle, right? So BMN, BMN and this angle CNM, CNM. And the second pair is, what is it? This angle means AMN, okay, AMN and this angle DNM. So this is the given in the statement. Now you have to write to prove. To prove means what you need to prove, what you want to prove, right? So you have to prove the pair of alternate interior angles are equal. So you have to write, you have to prove angle BMN is equal to angle CNM and angle AMN is equal to angle DNM. Right? So you have to prove these two statements. So now we will start how to prove it. Okay? So proof. Right? See, whenever the line PQ intersect the line AB, okay, then how many angles are formed? Forget about CD. PQ, AB. Then 1, 2, 3, 4. 4 angles are formed, and out of the 4 angles, two pair of opposite angles are known as vertically opposite angles. Yes or no? Yes. So here you can write this angle and this angle are vertically opposite or not? Yes, they are vertically opposite angles. Okay. So PMB angle is equal to this angle AMN. Right? So what is the reason? Because vertically opposite angles. Understood? So first I have written this angle is equal to this angle because they are vertically opposite angles. Okay? Next, since according to the axiom 6.3, whenever a line, transversal line intersect two parallel lines, then corresponding angles are equal, right? So here, what is the corresponding angle of this angle? What is the corresponding angle of this angle? This angle and this angle are corresponding or not? Yes, they are corresponding because they lie on the same side. They are not adjacent, as well as one lies towards the exterior, one lies towards the interior. So this angle and this angle, this angle and this angle are corresponding. Okay, according to the 6.3 axiom, the two corresponding angles are equal. Okay, H, according to axiom 6.3, this angle and this angle are equal. PMB is equal to this angle, means MND, or you can say DNM. Either you write MND or DNM. So is equal to DNM. Understood? Now you can write this as equation 1 and this as equation 2. Okay, first we take PMB is equal to AMN. PMB is equal to ANN. So these two are vertical opposite angles, so they are equal. Second, we have taken that this angle are equal. Why? Because they are corresponding angle. You can write the reason corresponding right? So now you have to compare these two equations. Compare these two equations. In the first equation you get PMB is equal to AMN. In the second equation you get PMB is equal to DNM. Now you can see in these two equations the left hand side are equal. Yes or no? Here the left hand side is PMB. Here also the left hand side is PMB. If the two equations there left hand side are equal, then you can write that their right hand side are also equal. Okay. So by comparing equation 1 and 2, we get, what do we get? We get that RHS are equal. AMN angle is equal to D and M angle. D and M angle. Okay, we finally get this result by comparing the equation 1 and equation 2, because equation 1 and equation 2 have same LHS, hence they must have same RHS. Okay, so finally we get angle ANM is equal to angle DN. Now you can see this is the proof 2 or not. We have to prove this statement. AMN is equal to DNM, and we proved it. Okay, so this is proved 2. Understood how we proved it? So we have proved the second statement, that the angle AMN is equal to the angle DNM, right? So here in this figure the angle AMN, that means this angle is equal to the angle DNM. Okay, so these two angles are equal, and these two angles are also known as alternate interior angles, right? So from the theorem 6.2 we get an idea that whenever a transversal line intersect any two parallel lines at two distinct points, then the pair of alternate interior angles are equals, right? Now we will prove the first statement, that the angle BMN, this angle is equal to the angle CNM, this angle. Okay, so now we will prove whether this angle and this angle are equal or not. Okay, so let's prove. Now let us consider the straight line PQ and the line AB. Forget about the line CD, forget it. Now the line PQ and the line AB intersect each other at a common point M, right? Then two pair of vertically opposite angles are formed. Understood? So according to the theorem 6.1, the vertically opposite angles are equal. Okay, so whenever the line PQ intersect AB, we have two pair of vertically opposite angles. This angle are vertically opposite, and this angle are vertically opposite angles, and the vertical opposite angles are equal according to the theorem 6.1. okay, so now as we have this angle is equal to this angle because they are vertically opposite, so you can write the angle PMA or AMP, whatever you can write. The angle AMP is equal to the angle, this angle BMN. What is the reason? Because they are vertically opposite angles. This is equation 1. Okay. Next, this angle, okay, is equal to this angle. Why? What is the reason? Because these two angles are known as corresponding angles. Because these two lie on the same side, they are non-adjacent, and one lies towards the exterior, one lies towards the interior. Hence, this angle and this angle are equal. Why? Because according to the axiom 6.3, if a transversal line intersects any two parallel lines, then the pair of corresponding angles are equal. Hence, these two angles are equal. So you can write the angle PMA, okay, or you can write AMP. So the angle AMP is equal to this angle, right? So these two angles are equal. This angle means the angle CNM is equal to CNM. Why? Because they are corresponding angles. According to Axiom 6.3. Right? Now suppose this equation is equation 2. Now we will compare this two equations. Okay? So comparing equation 1 and equation 2. Now you can see in the equation 1 and in the equation 2, the left hand side are equal. Here the left hand side is AMP angle, here also AMP angle. And we know if in two equations the left hand side are equal, then we can write that their right hand side must be equal. Hence we can write the right hand side of equation 1, that is BMN, is equal to the right hand side of equation 2, that is CNM. CNM. This is the result that we find by comparing equation 1 and equation 2. Right? So we get the angle BMN. BMN, that means this angle is equal to the angle CNM. CNM, this angle. And these two angles are alternate angles, and we need to prove it here. See, BMN is equal to and CNM is equal to CNM. Hence, it is proved that the pair of alternate angles are equal. Okay, this is the axiom, this is the theorem number 6.2. Okay, now from this theorem 6.2 we get an idea that if a transversal line intersects any two parallel lines, then two pair of alternate interior angles are equal. Okay.